Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we will review index laws. So the 7 index laws you would have previously learned are here. We'll go through them one by one, but firstly we need to make sure we understand that this is called the base and this the index, and I'll use these terms a lot. So the first index law is saying if you multiply the same base, here the base is A, then you simply add the powers or the indices. So if you have something like x to the power of 8 times x, remember x is the same as x to the power of 1, you just keep the same base and add the indices. If you have a situation where you have different numbers and pronumerals, just do them separately. So to do this, I just go 2 times 3 is 6, x to the power of 4 times x to the power of 6, keep the same base and add the indices. So the second index law says when you divide the bases, you subtract the indices. So if you have something like x to the power of 7, note this line here, fraction line means divide, x to the power of 3, you simply keep the same base and subtract the powers. The third rule says if you have a power raised to another power, keep the same base and multiply the powers. So if you have something like x to the power of 7 to the power of 6, keep the same base and multiply the two powers, 7 times 6. The fourth index law says anything except 0 when raised to the power of 0 is 1. So 2 to the power of 0 is 1, 3 to the power of 0 is 1, and so on. So if we have something like 3x to the power of 0, and we're told x is not equal to 0, that would just be 3 times 1, which is 3. Make sure you understand order of operations. BIDMAS, I stands for indices. So index comes before multiplication. So x to the power of 0 is 1. That's how we got 3 times 1. We have to do the power first here. Of course, if we had something like 3x all raised to the power of 0, that would just equal 1. Because of the brackets, we do the multiplication first here. Right, index law 5 says if you raise a fraction to a power, simply raise the numerator to that power and raise the denominator to that power. So let's say you had something like x to the power of 5 over y to the power of 6 all raised to the power of 3. You just raise the top to that power. So we're also using power to a power rule here, multiplying the indices. And on the bottom, we raise y to the power of 6 to the power of 3, and we get that. So index law 6 says the power of a product is the product of the powers. You just raise the first thing in the product to the power and the second thing in the product to that power. So if you have something like 3x to the power of 7 all raised to the power of 4, people always forget you have to raise 3 to the power of 4 as well. So it'll be 3 to the power of 4 is 81, and then x to the power of 7 to the power of 4, keep the same base and multiply the powers. So index law 7 is about negative indices. So if you have a negative index like that, you can just put it on the bottom of a fraction and write it with a positive power. So if you have something like x to the power of minus 3, it just goes to the bottom of the fraction, but with a positive power. So if you have multiple things like this, so what you do here is anything with a positive power goes on top. So that's the minus 4 and x to the power of 4. Anything with a negative power goes on the bottom, but you write it with a positive power. Now just note here, negative 4, yes, it's a negative number, but it doesn't have a negative power. Negative 4 is a base, not an index. That's why it went on top. Negative 4 is actually the same as negative 4 to the power of 1. That's why it has a positive power. That's why I put it on top. Now, if you have a fraction to a negative power, a quick way you can simplify this is flip the fraction, so exchange the numerator and denominator, and make the power positive. So here I just get y squared to the power of 4, multiply the powers, x to the power of 3 to the power of 4, multiply the powers. All right, let's now look at some harder examples. So let's have a go at using index laws to solve this equation. 9 to the power of x equals 27 to the power of 27. So the reason that this is quite a difficult question is because we have different bases here. And all of the index laws on the previous slide basically told us what to do when we have the same base. What we can do though is we can write these so they have the same base. You see, both 9 and 27 are powers of 3. So 9 to the power of x is equal to 3 squared, because that's 9 to the power of x. 27 is equal to 3 cubed. So this here is equal to 27 to the power of 27. Now we can use the power to a power rule, which says that if you have a power to a power, you keep the same base and multiply the powers. Keep the same base and multiply the powers. So now we have the same base. For these expressions to be equal, the powers must also be equal. So we must have 2x equals 81, dividing each side by 2, I get x equals 81 over 2, or 40.5. All right, let's have a go at simplifying this one. We're going to need quite a few index laws here. So let's first look at this term here. Well, the 25 is not in the bracket, so it's not getting raised to the power of 4. So I'm going to leave the 25 as it is. I'm going to raise x to the power of 8 to the power of 4, and similarly for the y cubed. We use the power of a power rule there. So here we have, again, a product to a power, so we're going to raise 5 to the power of 3. We're going to raise x to the power of 5 to the power of 3, and similarly for the y to the power of 6. Now, what I said at the end of the previous slide is that if you have a fraction to a negative power, what you can do is flip the fraction and make it a positive power. So I'm going to change this to positive 2. But note that because we are dividing, when you divide a fraction, you flip it and make it a times. So I'm going to flip this fraction again and change this to a times. So now what I'm going to do is I'm going to take this fraction, raise to the power of 2. So I'm going to raise the top to the power of 2 and the bottom to the power of 2. Alright, now I'm ready to simplify this whole expression. You can cancel at this stage, or you can multiply the tops, multiply the bottoms, and then cancel. It doesn't matter. So at the top, 25 times 25 is 625. We'll combine the x's, so keep the same base, add the powers. There's nothing for the y to add to, so I'll leave it alone. So on the bottom, we get 125. There's nothing for the x's to multiply by, but for the y's, I'll keep the same base and add the powers. All right, let's now go and simplify this. So 625 divide 125 is 5. X to the power of 40 divide x to the power of 15. So what you do is keep the same base and subtract the powers this time. Now we have y to the power of 12 over y to the power of 30. Well, to do that, we keep the same base and subtract the powers. I'd get y to the negative 18. So what I do there is I put the y to the negative 18 on the bottom of the fraction, but write it with a positive power, and then I'm done. All right, thank you so much for tuning into this video. This has been the luckiest maths teacher in the world. Have a great day.